देखिए मैंने कुछ कैमरा ऑन नहीं है क्या? विदाउट कैमरा का देना है। नो प्रॉब्लम। स्क्रीन तो दिख नहीं रहा है। हाँ रुको, आ रहा आना शुरू हो गया। Today I'm going to start determinant and matrices. Okay.
Okay, sir.
First we learn determinants. हैंडबुक लेके आया तो determinant is a value. Symbol of a determinant is two vertical lines. So if I will do it. Symbol of determinants is colliding with symbol of modulus. Okay. So you should not confuse with modulus and determinants. Determinants give the algebraic value. When nothing is said about two vertical lines, it means it will be a determinant. When it is said that two vertical lines represent a modulus, you should consider it as a modulus. Modulus always gives 0 or more than 0 value. That is, modulus is a non-negative function. Modulus is a non-negative function. A determinant gives the algebraic value. That means determinant can be positive, can be negative, can be 0. That means determinant is a abbreviation or shorthand representation of long expressions. Okay. What is determinant? Determinant is an abbreviate form or shorthand representation, shorthand technique to represent a long expressions. Okay. Or expressions. Okay. Or expression. Understood? Saksham?
Yes, sir.
Suppose that I have AD minus BC. I can represent this under determinant as AB, CD. A will multiply with D. Formula will take minus AD. Then with formula I have to take minus. Then BC will be cross multiply. Okay. Then BC will be cross multiply. Right? Any problem? Now I will learn minor and cofactors. Okay. Then expansion of determinant. Minors and cofactors. First, we will learn minor. Suppose that I have a determinant A11, A12, A21, A22, minor of A11, I will write this M11. I will delete row and column along A11. So I have to delete this and this. So we're left with the determinant of 1 by 1 order. A22. This is a 1 by 1 order. This is equal 2 by 2 order. Horizontal elements form the row and vertical elements form the columns. Understood, everyone? I have limited times. That's why I will speak many things within one conditions, okay? Within one headings. Understood, everyone?
Yes, sir.
So the horizontal elements form the rows and vertical elements form the column. So A11 and A12 is first row. A21, A22 is second row. A11 and A21 is column 1, yeah, first column. A12, A22 is second column. Understood, Saksham? Saksham? Are you there? Saksham? Saksham?
Yes, sir.
Understood this? First row contains A11, A12. Second row contains A21, A22. First column contain A11, A21. Second column contain A12, A22. Any problem?
No, sir.
So the minor of A11, I will delete row and column along A11 and take the determinant of rest elements. So only one element left, A22. and A22 is 1 by 1. So we 2 by 2, that means 2 row, 2 column. 2 by 2 means 2 row, 2 column. 1 by 1 means 1 row, 1 column. So this will be A22. Understood? Saksham?
Yes, sir.
Now minor of A12, I'll have it M12. So I will delete row and column along A12. So we left with A21. Determinant. This will give you A21. Minor of A21. I will delete row and column along A21. I will left with A12. Determinant. This is A12. I'm not saying modulus, I am saying determinants. Minor of A22, M22. Row column delete along A22, you will left with A11. Understood? Tell me.
Yes, sir.
Suppose that I'm writing a determinant example, especially for Saksham, because I think here Sainik School you know the determinants very well. A11, A12, A1n, A21, A22, A2n, dot, AN1, AN2, ANN. This will be written as n by n. This will be written as the first n will be number of row and the second n will be number of column. Understood, Saksham?
Yes, sir. Understood.
Now suppose that I am writing exam element Aij. This represents row number. I represent row number. J represent column number. So this will read as element of ith row and jth column. Understood? Saksham?
Yes, sir.
So A11 is the element of first row, first column. A21 is the element of second row, first column. A22 is the element of second row, second column. A12 is the element of first row, second column. Understood?
Yes,
Tell
sir.
me.
Yes.
Basically, when I teach determinant when we have a more time, first I clear the definitions, terms, then start the calculations. But you have limited times, okay?
Yes, sir.
So this is called 2 by 2. Most of the time you will ask for 3 by 3 determinants. So I am writing 3 by 3. 3 by 3 will A11, A12, A13. A21, A22, A23, A31, A32, A33. I'm writing the reference here. Oh, each time I will not write reference. I'm writing reference only one times, okay? But where you will find 1 1, here you will find A12, where you will find 1 3, when you will find 2 1. Understood, Saksham?
Yes, sir.
So this horizontal line is first row. This horizontal line is second row. This horizontal line is third row. This vertical line, top to bottom. Here, for row will be count from left to right. And column will start from top to bottom. Understood?
Yes, sir.
Column 1. Then column 2. Then column 3. Understood?
Yes, sir. Understood.
Suppose that I have a determinant like this. A1, B1, C1. A2, B2, C2. A3, B3, C3. I want to find minor of A11. So M11 capital. In place of A11, you are seeing that you have A1. So you will delete row and column along A1. After deleting, you will get 2 by 2 determinants. That will be B2, C2, B3, C3. And according to 2 by 2 determinant, you will multiply this B2, C3 minus B3, C2. Understood, Saksham?
Yes, sir.
So similarly, if I want to find M12, in place of M12, you have B1. Along B1 row column delete. So you will left with A2, C2, C2, A3, C3. You will expand like that. A2 will be multiplied with A3 and A3 will be multiplied by A3. In between you have to take minus. Understood?
Yes.
So similarly you will find all the minors. Similarly you will find all the. Here you have 9 elements, so you have 9 minors. In 2 by 2 you have 4 elements, so you have 4 minors. Here you have 9 elements, where you have 9 minors. Understood, everyone? Tell me.
Yes, sir. Understood.
Okay. Now the cofactors. Cofactors. Cofactor of cofactor of Aij is equal to, let I take capital Aij or capital Cij. This will be minus 1 to the power row number plus column number into minor ith row jth column. Understood?
सर ये नहीं समझा, कैन यू एक्सप्लेन दिस once
This is
again?
the formula of cofactors. Cofactor of element of ith row jth column is equal to, let's I take in symbolic capital Aij or in symbolic capital Cij. This will be equal to -1 to the power I plus j into minor of ith row jth column element. Understood?
Yes, sir.
So there is a relation between cofactors and minor. There is a relation between minors and cofactors. Suppose that you are taking A11 or C11, you will be get -1 to the 1 plus 1 M11. So you will get exactly what you get minor, the same you will get cofactor. Understood?
Yes, sir.
But suppose that you have A12. So C12 -1 to the power 1 plus 2 M12. So you will get negative of M12. So here the value will be same, but sign will be reverse. Of minor, you will get the cofactors. Understood?
Yes, sir.
That means when the subscript sum is odd, then cofactor will be minus time minor. And when some sum of subscript is even, then cofactor equal to minor. Understood, everyone?
Yes, sir.
So cofactor sign for 3 by 3. Three by three. For first element A11, you will get plus cofactor sign. That means for first element, minor equal to cofactor in the first row. Second element in the first row will be negative. That means you have to multiply negative sign. You have to multiply minor of second element of row with a negative sign. Then you will get cofactor. Understood? Then for third element, you will get plus, because in third element you have 1 3. 1 3 is 1 plus 3 is even. Now here you will get minus, but in place of 2 1. 2 plus 1 is 3. In place of 2 2, you will get plus, minus, plus, minus, plus. Alternate you can take plus minus plus minus. Understood, everyone?
Yes, sir.
Saksham,
Yes, sir. Understood.
you have understood this. Now I will expand determinant. So expansion of determinant. Expansion of determinant. Suppose that I have a 3 by 3 A1, B1, C1, A2, B2, C2, A3, B3, C3. I want to expand this. We can expand any row or any column. We can expand in any row or in any column. So, Saksham, tell me, in which row or column you want to expand? Saksham?
Second row, second column.
No, you have to choose only column or only row.
Second row, sir.
Second row. So in place of second row, the cofactor sign is plus minus in the first column. So in place of A2, you will get minus as a cofactor sign. Understood?
Yes.
Here you can see that in the second row, first is minus. Understood?
Yes, sir.
So minus A2. Now delete row and column along A2. So you will get B1, C1, B3, C3. Then in place of B2, the sign will be positive. Here you can see minus plus then minus. So before B2, you will take positive. Now along B2, you will delete row and column. So after deleting row and column along B2, you will get A1, C1 and A3, C3. Understood? Tell me.
Yes, sir. Understood.
Then for C2, minus plus then minus. So minus C2 determinant. Along C2 you will delete row and column. You will get A1, B1 and A3, B3. Now you will expand finally minus A2. When you will multiply B1 with C3, so B1 C3 and multiply C1 with B3, so minus B3 C1 plus B2. Similarly, A1 C3 I will write C3 A1 minus C1 A3, then minus C2 C2 I have to write here you will get A1 B3. A1 B3 minus A3 B1. Understood?
Yes, sir.
If you will expand any row or column, the determinant value will not change. The determinant value will not. Understood? सच्चा बहुत गुस्सा आ रहा है इस पे पेन पे मुझे.
Yes, sir.
Now see the property. Suppose that you have A11, A12, A13. Very, very important for NDA. I am writing A21, A22, A23, A31, A32, A33. This is the determinant delta. For the delta, suppose that you have taken A11 value, then cofactor along A11 plus if you have taken A12, cofactor along A12 plus A13, cofactor along A13. Understood? Tell me.
Yes, sir.
Now suppose that you have taken A11 but cofactor along A21. That means in corresponding elements of another row. Okay? A12, so A22. A13, that is A23 equal to 0. Similarly, you will get A11, corresponding element of A11 in the third row is A31, right? So cofactor A31, A12 corresponding in third row is A32, A13 corresponding A33. You can also write for columns. Can also write for columns. Understood, Saksham?
Yes, sir. Understood.
Very important. Now we can also write in minor terms A11, capital A1, sorry, capital M11, but here A12 is the negative of M12. So minus of M12 plus A13. A13 is equal to M13. Understood?
Yes, sir. But sir, in opening this, we first in the second row you have written A11, A21.
So suppose that you are taking elements from the first row and cofactor from the another row. Okay. So you have to take correspondings. Okay.
Okay, sir.
Corresponding to A11, you will find A21 in the second, and in the third A31. Understood?
Yes, sir.
Suppose that you are taking here A11. So here A21, 21 is a negative. So here negative will be negative of M21. Now A2, 22 is the positive. So here A12, so M22 and 23 odd, so will be negative. So A13, M23 equal to 0. Understood?
Yes, sir.
Right. So we have done expansion of determinants and with important points which you will ask in your examination generally in a statement based question. In statement based question, I told you, अरे उठा दो इसको रे, जगा दो उसको, देख ले याद होगा, पढ़ा हुआ है मुझे मालूम है लेकिन देख ले, कुछ चीजें मिसिंग रहती है. Saksham understood this?
Yes, sir.
Now after expansion of determinant, we'll go with properties of determinant. Okay?
Okay, sir.
Properties of determinants. Number 1. What is the first property? Sushil, tell me. If we interchange row and column, then value of determinant remains same. So I will write in symbolic form A1, B1, C1, A2, B2, C2, A3, B3, C3. The first property is if we interchange row and column, that is row go to column, column go to row, then value of the determinant remains same. So how you will get? First row I will write first column A1, B1, C1. Second row I will write second column A2, B2, C2. Third row third column A3, B3, C3. Now you can observe that row goes to column, column goes to row. Understood?
Yes, sir.
So value of determinant will not change. You don't have much time, you limited time, so I will not write a statement. I will write symbolic form. Okay. Is it okay, Saksham?
Yes, sir.
Now, property number second. If we interchange any two row or any two column, if we interchange any two row or any two column, then the value of determinant, then the sign of the value of determinant will change. Sign of the value of determinant will change. That means if the value of determinant is positive, then it will be negative. Then it will be a positive, it will be a negative. Understood?
Yes.
So I have A1, B1, C1, A2, B2, C2, A3, B3, C3. Saksham, tell me which row, which two row you wish to change. Tell me.
Sir, first and third.
First and third. So I will write third in place of first. A1, A3, B3, C3. And second will be in place of as it is. And first will go in the third place. So A1, B1, C1. So the value of the determinant will reverse. It is, if it is positive, it will be negative. It is negative, it will be a positive. So I have to take minus. Now, which column you wish to interchange? Which two column? Tell me.
Sir, second and third.
In column, only two column. Tell me, only two column. You tell second and third or first, third. Tell me. Saksham? Saksham? Saksham, I'm not getting your sound. You are not audible here. Irfan Atullah, where is Nivedita? Why is speaking? Tell me. Saksham, check your sound. Suppose I check second and third column. So A1 will be as it is. A1, A2, A3. Third column will be in the second place. In the second column. C1, C2, C3. And second column will go to the third column. B1, B2, B3. And I have to take minus here. Understood? Saksham?
Yes, sir.
Now you are audible. Hold for 2 minutes. कल अपनों के लिए यौम आजादी है ना
प्रॉब्लम टू सर
आके सामने पूछ ले सच सच पूरा पूछ ले। ये बहुत अच्छी बात है कि पेपर क्लियर कर ले आ गया, जो पेपर में डाउट है ना सामने क्लियर करा गया। ये करके आ रहे, मैंने बोला हैंडबुक लेके आने के लिए, सागर को फोन कर हैंडबुक लेके आने के लिए। नाउ लिसन, if any two row or any two column are proportional to each other, then value of the determinant will be 0. Understood, Saksham?
Yes, sir.
So here suppose that K, KB, KC, A1, B1, C1 MA, MB, MC, then the value of determinant will be 0. Value of determinant will be 0. Saksham?
Yes, sir. Understood. 0.
Similarly, this will be also 0. How? Let's K, KB, KC, ABC, A1, B1, C1. This you will also get 0. Okay?
Yes, sir.
Fourth, if any two row or column are identical, then the value of determinant will be 0. A, B, C, A1, B1, C1, A, B, C, A1, B1, C1, A, B, C, A, B, C, you will get 0. Understood? Achha?
Yes, sir.
Now the fifth, if any row or any column is 0, if any row or any column is, then the value of determinant will be 0. Suppose that A1, B1, C1, A2, B2, C2, 0, 0, 0, or 0, 0, 0, A1, B1, C1, A2, B2, C2, you will get 0. Understood?
Yes.
yes sir
The fourth. Now the fifth. You can take common. You can take common from any one row or any column. You can take common factor. Suppose that I have K, KB, KC, Here M also. Here M B1 C1 A2 MB2 C2. From first row I can take K common. From first row I can take common as a K. Or from second column I can take common as a M. We will get ABC A1 B1 C1 A2 B2 C2. Understood?
Yes.
That means we can take common factors from any one row or any one column, or we can multiply any common value to any one row or any one column. Understood? Saksham?
Yes.
The fifth case. Now the sixth. Sixth is, suppose that I have A1 plus A2, B1 plus B2, C1 plus C2, alpha, beta, gamma, alpha 1, beta 1, gamma 1. I can separate it. A1, B1, C1, alpha, beta. Second column and third column will be remain as it is. Alpha 1, beta 1, gamma 1. Plus, now first row here A2, B2, C2, and first column. And second column, third column remain as it is, alpha, beta, gamma. Alpha 1, beta 1, gamma 1. Understood, Saksham?
Yes, sir.
I can also do for column wise. Suppose alpha, beta, gamma, A1 plus A2, B1 plus B2, C1 plus C2, alpha 1, beta 1, gamma 1. So this will be, alpha will be, first row remain as it is, alpha, beta, gamma. Here I will take A1, B1, C1, then alpha 1, third row as it is, alpha 1, beta 1, gamma 1, plus. Saksham, I didn't understand how you learn competitive questions if you don't know properties of determinant. How you learn? I can't imagine.
Sir, I only know expansion, opening of determinant, how to solve it.
I know
Using
it, but I'm not digesting that. How you know, how you solve the competitive questions, big competitive question, that is merit based questions without property. Who is teaching you? JE?
sorry.
I can't imagine. With determinant is a fundamental things. Mathematics is a fundamental things. To teach everything. Trigonometry is the fundamental things. And equation is the fundamental things. Okay?
Yes.
Sets, relation, function, equation, inequations, determinant, matrices, and some concepts of sequence and series. These are the fundamental concepts to teach big chapters. Okay?
Yes, sir.
Saksham, understood?
Yes.
So alpha, beta, gamma, this will be the format you will expand. Now the very, very important things. Seventh case, row column operations. Row, column, Here nothing is important. Principle is very important. I will only write rules. Suppose that I want to change my ith row. That means I want to transform my ith row. How I can transform? I can transform ith row plus or minus you can take, and suppose that you are taking any scalar value alpha, or you multiplying with jth column, jth row. You can also multiply or add or subtract another row. That means suppose that I am taking x value beta and rk. Understood?
Yes, sir.
If you will change C transform C, Ci plus or minus alpha, Cj plus or minus beta Ck, then value of determinant remain as it is. Value you cannot multiply Ri or Ci with any scalar quantity, okay? With any scalar quantity, you cannot multiply. You have to keep it as it is.
Okay, sir.
So value of determinant will not change. Remains as it is. Understood?
Yes, sir.
Now I have finished properties of determinant. Call the Sagars. Tell him that. Face the handbook for me. Now, after this, I will start matrices. Do you know definition of matrices, Sakcha?
No, sir.
No. So matrices is the collection of data in row and column ways.
About it.
Matrices is the collection of data in row and column ways. Understood? Determinant is a value. Matrix is the collection of data. Any problem?
No, sir.
Suppose that I have A1x, B1y, C1z equal to D1, A2x, B2y, C2z equal D2, A3x, B3y, C3z equal D3. Let's I collect coefficients only first. So coefficient of variable in the first row I will collect A1, B1, C1. Coefficient of variable in the second row I will collect A2, B2, C2. Coefficient of variable in third equation I will collect in third row A3, B3, C3. Variable collect in vertically X, Y, Z. Constant I will collect vertically equal to D1, D2, D3. The first collection I will tell capital A. The second collection I will tell capital X, and equal to the constant collection vertically I will say B. This is called matrix equations. This is called matrix equation. Understood, Sacham?
Yes, sir.
So symbol of matrix. You will take a square bracket or this parenthesis. A square bracket means you should not confuse with it with greatest integer. Okay.
Yes.
When greatest integer said, you think it will be greatest integer. When it is not said greatest integer, you will think it is a matrix. Understood?
Yes, sir.
Good. Now you can see here, you have in A matrix, name of matrix will be generally represented by capital alphabet. So A1, B1, C1, A2, B2, C2, A3, B3, C3, right? So this has 3 row, 3 column. 3 row, 3 column. So I will form a let's say collection of data like that. A1, 1, A1, 2, dot, 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 A1N, A21, A22, dot, 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 A2N, AM1, AM2, dot, dot, AMN. The size of this is M by N. The size of this is M by N. Saksham understood?
Yes, sir.
So number of row here M. Number of column here N. So we learn is M by N. M cross N. Right? This is called size of matrix. So matrix in the form of rectangular structure. Okay. Matrices will be in the form of rectangular structure, right? A square is the special case of rectangle. That means every square is a rectangle, but every rectangle is not a square. Understood, Saksham? Atulya?
Yes, sir. Understood.
Yes, sir.
Atulya?
Yes, sir. Understood.
Ripan? This is what you should think, that every rectangle cannot be a square, but every square is a rectangle. Okay. So for determinants, we have always a square structure. For determinants, we have always a square structure. That means for determinant, number of row equal number of column. But for matrices, number of row may be equal or unequal to number of columns. Okay.
Yes, sir.
You know what is the here row, what is the column? I already explained this in determinant. Okay.
Yes, sir.
Horizontal lines constructing the row and vertical line constructing the columns. Okay.
Yes,
Right.
sir.
From top to bottom, I will take number of row. I will start from top to bottom. Okay. Right. First row, second row, third row. From left to right, I will consider columns. First column to nth column. Understood?
Yes,
Yes,
sir.
sir.
Now I have explained the definition of matrices. Now types of matrices. So I will only tell the words. rectangular matrices when number of row, suppose that I am writing number of row is m equal to m, number of column n. So if m not equal to n, it is called rectangular matrices. It is called matrices. Suppose that I have a matrix A with m cross n and m not equal to n. Number 2, after rectangular, horizontal matrices. What the horizontal matrices? Suppose that I have m cross n. In horizontal matrices, number of column will be more. So m less than n. That's called horizontal. That's called horizontal. Third, vertical matrices. I have a matrix m cross n. Here number of row more than columns. Okay. Understood?
Yes, sir. Understood.
Number 4th, row matrix. What is row matrix? Sorry, row matrix only one row. Only one row, okay? 1 cross m, n. Here n not equal to 1. Here n not equal to 1. 5th, column matrix. Column matrices. A, only one column. Here m not equal to 1. Understood everyone? Tell me.
Yes, sir.
Understood.
6th, a square matrix. In square matrices, number of row equal number of column. N cross n. Okay? Right? Before a square matrix, I should write null matrix. Okay? Because after a square matrix, I will deal every types of a square. Okay? So null matrix. Each element 0. 0, 0, 0, 0, 0, 0. Right? Every element 0. Then it is called null matrix. Tell me, understood?
Yes, sir.
Yes.
7th, a square matrix. Square matrix, you will be n cross n. That is number of row equal number of column. Now I will start the type of square matrix. First is diagonal matrix. Okay? Diagonal matrix, suppose that n cross n, Aij, n cross n, I have Aij equal to 0, for all I not equal to j. For all I not equal to, this is the diagonal matrix 0, 0, 0, B, 0, 0, 0, C. Understood? This is the 3 by 3 diagonals. Tell me,
Yes, sir.
Aksham.
Understood, sir.
Understood. Now after diagonal, you have another types, a scalar. It will also a square form. Aij n cross n. Aij equal to 0, I not equal to j, and equal to k, k not equal to 0, for I equal to j. Understood? Tell me.
Yes, sir.
So this will be like that. K 0, 0, 0, K 0, 0, 0, K. Okay? Tell me, understood?
Yes, sir.
Yes,
Understood.
sir. Understood.
Now unit matrix. In unit matrix, Ij n cross n. I will write this is In when Aij, when Aij equal to, let's say write equal to 0, I not equal to j, 1, I equal to j. For 3 by 3, I will write the example. For 2 by 2, I2. For 3 by 3, I will write I3 1 0 0 0 1 0 0 0 1. Right? Tell me everyone.
Yes, sir. Understood.
I have done row matrix, column matrix, null matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, rectangular matrix, horizontal matrix, vertical matrix. Now triangular matrix. Okay. Now 11th is triangular matrix. In triangular, you have two types. First is upper triangular. Upper triangular matrix. What is upper triangular matrix? Tell me. Suppose that A, this will also a square form. So here, Aij is 0 for all which I greater than j. For I greater than j, this will be 0. That means what? 3 by 3. Upper triangle ABC, 0 DE, 0 0 F. This is called upper triangular. Understood everyone?
Yes, sir.
Yes.
You can see here, here a triangle is forming, right? 0 0. Okay?
Yes, sir.
Now lower triangular matrix. Lower triangular matrix. Ij n cross n. Here Aij is 0 for all I less than j. For all I less than j. whatever you will get after deleting a row and column along a elements of the matrix. After deleting row and column along elements, what you find remains, that will be called a submatrix. That is called a submatrix. That means minor is a submatrix. Minor is a submatrix. Understood, everyone?
Yes,
Sub submatrix. Submatrix has no use, so I am not going to give the example. Sum of matrix, the addition of matrix. Now, principal diagonal of the matrix. Before that, singular matrix. You have learned triangular matrix. Now singular matrix. 11th number. Now the 12th number. Singular matrix. Determinant A equal to 0. Then it is called singular matrix. Non-singular matrix. Determinant of matrix is not equal to 0. Understood? Tell me, hurry up.
Yes, sir.
Now the 14th point. Principal diagonal. आज ही खत्म. Suppose that you have A1, B1, C1, A2, B2, C2, A3, B3, C3. From left hand side top corner to right hand side down corner, bottoms, that is bottom, the red ink represent the element of principal diagonal. Okay, this is the principal diagonal. When I say diagonal, it means I am calling principal diagonal. I repeat, when I say diagonal, I means I am repeating, I am calling principal diagonal. Understood, everyone?
yes, sir.
Good. Now, equal matrix. Now, algebra of matrices. I will start. Algebra of matrices. Equality of matrices. Two matrix will be equal if corresponding elements are equal and orders are same. X, Y, Z, W. Here you will find four equations, simultaneous equation. First simultaneous equation, K equal to X and B equal to Y and C equal to Z and D equal to W. Understood, everyone?
Yes, sir.
These are AND equation, simultaneous equation. So two matrices will equal if and only if orders are same and corresponding elements are same. Understood, Saksham?
Yes, sir, understood.
Now, addition of matrix. Addition of matrices. Suppose that I have A1, ABC, AB, CD and XYZ, W. Two matrices can be added if order are same. If order are same, then two matrices can be added or subtracted. And we should add or subtract corresponding elements. So A corresponding to X. So A will plus X, or let's I will take minus after that additions. A plus X, B will add with Y, C will add Z, D will add with W. Suppose that you are subtracting the matrices, so A minus, 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 minus. Understood, Saksham?
Yes, sir.
Addition and subtractions.
Yes, sir. Understood.
Now multiplication of matrices. A, B, C, D. Alpha, beta, gamma, delta. Right? Suppose a matrix has M cross N and second matrix has N cross P. That means number of row in the first matrix, number of column in the first matrix equal to number of row in the second matrix equal. Then you will find, here I should write capital form, capital A, capital B. So you will finally get AB as a M cross P. Understood? This is called multiplication condition. Very, very important. Multiplication condition is very, very understood, Saksham?
Yes, sir.
मैं दूसरा चीज पे हंस रहा हूँ, मैं रेलगाड़ी की तरह चल रहा हूँ इसलिए। इतना कहीं फास्ट भागते देखा हमको क्या? टाइम ही नहीं रहे, क्या करो? मल्टीप्लाई रो बाय कॉलम, row by column. So you will multiply row with column. So first row, first column will multiply A into X. I will plus B will multiply with Z, BZ. Then first row, second column, AY plus BW. Now for second row, first column, CX, DZ. Now second row, second column, CY, CW. Right? Understood, Saksham?
Yes, sir.
Now we cannot divide matrices ordinarily. Okay, we cannot take division of matrices in ordinary conditions. When we are dividing, it means we are finding the inverse. Inverse I will told you later on. Understood, Saksham?
Yes, sir.
Good. 12th में नहीं मान पुणे में हो ना तुम? कौन से कॉलेज में हो अच्छा?
Sir, Cambridge.
कैम्ब्रिज में. Now transpose of matrices. Transpose of matrices. So transpose of matrices. Suppose that I have A1, B1, C1, A2, B2, C2, A3, B3, C3. When you are taking transpose, that means A dash is the transpose. Row will go to the column will go to the row. So first row, first column, A1, B1, C1. Second row, second column, A2, B2, C2. Third row, third column, A3, B3, C3. So you can see your column will go into the row. Understood, everyone? Tell me.
Yes,
You
sir.
can also represent A to the power T. as A dash. Understood? Saksham?
Yes, sir. Understood.
Now we'll take some more special case, a special type of matrix. Orthogonal matrix. Very, very important. Orthogonal matrix. A transpose multiply or A transpose A, you will get unit matrix. Understood? Tell me.
Yes, sir.
Now idempotent matrix. Idempotent matrix. Okay. Saksham?
Yes, sir.
Now involuntary matrix. Involuntary matrix. Involuntary. INVOLUTRY. Involuntary matrix. When you find A square as a unit matrix, then matrix is called involuntary matrix. Understood? Tell me.
Yes, sir.
Now nilpotent matrix. Nilpotent matrix. When A raised to K equal to 0. When A raised to K equal to 0, A is called nilpotent matrix. K is called order of nilpotent. K is called order or index. Order or index of nilpotent. Periodic matrix. When you find A raised to K plus 1 equal to A is called periodic matrix. K is called period of the matrix. K is called period. K is called period. Understood? Raksham?
Yes, sir.
Sixth. In term I have to teach first of all. I will take conjugate. Suppose that I have a matrix A1 plus iota B1, C1 plus A2 plus iota B2, A3 plus iota B3, A4 plus iota B4. I am taking conjugate. So we will take conjugate of every elements. So conjugate of A plus A minus iota B1, A2 minus iota B2, A3 minus iota B3, A4 minus iota B4. Now conjugate transpose is A power theta. I represent it. I represent it. I repeat, I represent it. Conjugate transpose A power theta. The A1 iota B1, A2 minus iota B2. Row will go column will go row. A3 iota B3, A4 iota B4. Understood, Saksham? Tell me.
Understood, sir.
So here I will teach you Unitary matrix. Unitary matrix. In unitary matrix, A power theta. First of all, let's A power theta or A power theta A equal to unitary matrix. Understood?
Yes, sir.
Good enough?
Yes, sir.
सर इरफान कौन है सर? स्टूडेंट से सर उसका कभी आवाज भी सुनाई नहीं दिया देता है, बोलता है जब लगाता तो बोलता है आवाज देता है now adjoint adjoint of a matrix. What is the adjoint of a matrix? Later I will represent adjoint of a matrix. Adjoint A ADJ of A or ADJ of A. This is called transpose of conjugate. Sorry, transpose of cofactor matrix. Transpose of cofactor matrix. Suppose that you have the matrix capital capital A11, A12, A13, A and A21, A22, A23, A31, A32, A33, cofactor matrix. Let's I take capital C, A11, A12. In place of a small A11, I will write cofactor of that A12, A13, A21, A22, A23, A31, A32, A33. Now here I will take adjoint A, that is transpose of C. You will get A11, A12, A13, A21, A22, A23, A31, A32, A33. Understood, Saksham? Tell me. Saksham,
Yes, sir.
okay? Now, inverse of the matrix. Inverse of a matrix by adjoint method. If determinant A not equal to 0, then inverse exists. Very, very important. That means for non-singular matrix, inverse exists. For singular matrix, inverse does not exist. Understood, Saksham?
Yes, sir.
Okay. Now, what is the inverse? So, A inverse is equal to determinant A adjoint A. Determinant A adjoint A. Okay? Right? You will get A inverse. A inverse A equal to unit matrix. Identity matrix. Tell me. Understood?
Yes, sir.
Yes, sir.
Okay. Now, I will teach you very, very important thing from where certainly a question will ask. Called application of determinant or matrices one property, very, very important, learn this. Suppose that I have the determinant, the first row or first column I am taking variables A, B, C, A1, B1, C1. If I will differentiate this determinant with respect to X, first row will be differentiate with respect to X and the remaining row will be as it is because A, B, C, A1, B1, C1 are constant. Understood? Tell me.
Yes, sir.
Very, very important. That's why I taught you. Now, system of linear equations. System of linear equations. First, non-homogeneous equation. Let's take three variables. So a1x plus b1y plus c1z, d1, a2x b2y c2z equal to d2, a3x b3y c3z equal to d3. You will take delta is equal to a1 b1 c1, a2 b2 c2. Listen carefully, Sunny School. These are very, very important things. I am teaching a system of linear equations. A3 b3 c3. Now delta 1 will be, I will replace first column with the constant d1 d2 d3. So d1 d2 d3, b1 b2 b3 will be as it is, c1 c2 c3 will be as it is. Now delta 2, replace second column with constant. So a1 a2, first column as it is, constant in the second column, d1 d2 d3, c1 c2 c3. And delta 3, first column second will remain as it is, a1 a1 a2 a3, b1 b2 b3. Now replace third column with constant d1 d2 d3. Now the very, very important things comes. First point, unique solution. Unique solution if delta not equal to 0. Delta not equal to 0. Unique solution. This called plane intersect at one point. Plane. ये plane का ही क्वेश्चन है. Plane intersect at one point. Plane intersect at one point. That means where what is x? X will be delta 1 upon delta. Y will be delta 2 upon delta. And Z will be delta 3 upon delta. This is called consistent system. This is called consistent system. Understood, Saksham?
Yes, sir.
Now, point 2. Infinite solution. Infinite solutions. That means if delta equal to delta 1 equal to delta 2 equal to delta 3, all 0. Planes are coincident. Planes are coincident. Understood?
Yes, sir.
Infinite solution. So this is called consistent system. Tell me, is it correct? May I go ahead?
Yes, sir.
Now the third point. No solution exists if delta equal to 0 and at least one of delta 1 comma delta 2 delta 3 non-zero. That is no solution. After that, you will get suppose that I take non-homogeneous for lines. So two variable system, okay? Earlier we have three variable system. So a1x plus b1y plus c1 equal to c1, I will write. a2x plus b2y equal to c2. So delta will be mod of, so mod, I say wrongly mod, determinant of a1 b1 c, a1 b1, a2 b2, delta 1. First column replace with constant c1 c2, b1 b2. Delta 2 a1 a2, second replace with constant. Now first unique solution exists. If delta not equal to 0, lines are intersecting, that means you will get like that. That means you will get a1 by a2 not equal b1 by b2, and here x will be delta 1 upon delta and y will be delta 2 upon delta. Understood? Right? This is the case of unique solution. Number 2, infinite solution. हम लोग रोज मोबाइल छीनना पड़ेगा, पता चलेगा। कल से शराफत से आके वहां पे मोबाइल रख देना चेयर पे। सबको बोल रहा हूँ, उधर ही मोबाइल दिख रहा है ना मुझे। कल से आते ही शराफत से वहां पे चेयर रखना, वहीं मोबाइल रखना। Infinite solution exists. So if delta equal to delta 1 equal to delta 2 equal to 0, infinite solution exists. That means A1 by A2 equal B1 by B2 equal C1 by C2. This called lines are coincident. Lines are coincident. हर एक वर्ड से इसमें क्वेश्चन बन सकता है, याद रखना. Lines are coincident. Number third, no solution exists. No solution exist. So delta, if delta equal to 0, Saksham understood? Saksham
Yes, sir.
understood?
Yes, sir.
If delta equal to 0 and at least one of delta 1 and delta 2 is non-zero. Is non-zero. That means lines are parallel. Lines are parallel. Lines are parallel. A1 by A2 equal B1 by B2 not equal C1 by C2. Okay. This is called inconsistent system. No solution is called inconsistent. When you have at least one solution, you will say consistent system. So infinite solution is a consistent system. This is also consistent. Here you will say inconsistent. Okay? Understood, Saksham? Atulya?
Yes, sir.
Now I will shift on homogeneous system. Very, very important, homogeneous system. Saksham, can you tell me what is homogeneous, what is non-homogeneous?
Sir, when degree of equation is same.
Degree of each term is same, homogeneous. And
Yes.
non-homogeneous when degree of at least one term is differ, okay?
Yes, sir.
Non-homogeneous. So, for homogeneous, three variable system A1x plus B1y plus C1z equal to 0, A2x B2y plus C2z equal to 0, A3x B3y plus C3z equal to 0. Right? So, we will only find your delta. A1 B1 C1, A2 B2 C2, A3 B3 C3. Okay? Understood?
Yes, sir.
Now, first case, unique solution. This is called trivial solution. What do you mean by trivial? Section, what do you mean by trivial?
Sir, don't know.
Which has no importance. Which has no importance. Unique solution, that means trivial solution. When you will get delta not equal to 0, that means all parameter will be 0, okay? When
Yes.
all parameter is 0, we have no importance of this parameter, okay?
Yes, sir.
No importance of this value, okay? When we take all parameters 0, then these value construct no importance. Understood?
Yes, sir.
So no importance. Which has no importance. सोच मैंने कितना टाइम खर्च किया होगा ये सब पे, ट्रिवियल नॉन ट्रिवियल पे, कितने फंसाते हैं लोगों को। इसी जो क्लियर करने में मेरे कितने दिन जाते थे। सर्च मारा, 10 फाइल पढ़े गूगल से, 10 फाइल पढ़ने के बाद वो कॉन्क्रीट डेटा तब मिलता था कि हाँ वर्ड असल मीनिंग क्या है। राइट नाउ इनफाइनाइट सॉल्यूशन। व्हाट इज इनफाइनाइट सॉल्यूशन? नॉन ट्रिवियल सॉल्यूशन। ओके, नॉन trivial solution. That means which has importance. Which has? That means if delta equal to 0. If delta equal to, that means which has importance. Understood, Saksham?
Yes, sir.
Now,
Sir, in trivial solution, there was also delta equal to 0, delta not equal to
no,
0.
trivial delta not equal to 0.
Okay, sir. Okay.
X, Y, Z all are 0. Delta not equal to 0. Okay.
Yes, sir.
And non-trivial delta equal to 0. Which has importance. Okay.
Yes, sir.
Now, two variable system. Two variable a1x b1y equal to 0. a2x plus b2y equal to 0. Homogeneous is consistent system. Okay. Homogeneous is always consistent system. I will write in the last, homogeneous are always consistent. a1x plus b1y, here delta is equal to a1 b1 a2 b2. Same case, delta equal to 0 non-trivial, delta not equal to 0 trivial, delta equal to 0 non-trivial, delta equal to delta not equal to 0, delta equal to 0 non-trivial, delta not equal to 0 trivial. Understood?
Yes, sir.
Homogeneous system always consistent. Always consistent. Right? Any problem?
No, sir.
Now I will go with the matrix version for non-homogeneous, non-homogeneous system. सोफिया मंग बोला तो non-homogeneous system. मैम देखो नहीं इसको क्या हुआ है यूट्यूब पे। बस छोड़ रहे हैं, 5 मिनट रुक जा, 3 मिनट बचे, 5 मिनट रुक जा। नॉन होमोजेनियस सिस्टम्स, A is